Hello, today we're going to talk about how to solve the problem of positive subset sum in recursion or in dynamic programming in top-down solution. Okay, so the question is, you're given an array of numbers like the following: A0, A1, A2 till A(n-1). Does some subset of this list sum up to exactly X? So for example, if we have an array of numbers of 5, 1, 3, 35, 56, 79, and X is equal to 138, how would you solve this problem then? The first solution that you might pop up might be to generate all subsets and add it up to compare it to X. But then when you generate all subsets, that's basically generating all supersets, which is 2 to the n sets in total. And then if you want to add it up and compare it to X, it takes n time. So the total time complexity would be O of n times 2 to the n, which is really, really costly. So you might want to think of another solution. And for these kind of solutions for array of numbers or like array of something, a really, really useful solution would be to use dynamic programming if the number is small, and or use recursion when the number is small. So how do you do recursion or dynamic programming in this case? The really, really important part is to divide the thing into subproblems. So in this case, when there's a list of numbers, you might want to omit one of the numbers and identify the different paths that they can go. So in this case, and if we have some subset of A0, A1, A2 till AK-1 can add up to X, where K is less than or equal to N, we can identify by thinking about, can we make X with just the first K of numbers? So basically the subproblems of that would be A0 till K-1, and we can see if we can make X with just the first K of numbers. And if we can, there are two possible cases. So one possible way is we can do without AK-1, and the second possible way is we can do it without AK-1. And there are different paths with these two solutions. So if we can do it without AK-1, then the same subset of A0 till AK-2 can also add up to X, because AK-1 doesn't contribute to the solution. So AK-1 would not be adding up to X eventually. If we can do it with AK-1, then the same subset omitting AK-1 could add up to X minus AK-1. So then we can identify the base case. If the set is empty, we can identify the base case if the set is empty. If the set is empty, that means that there's no numbers for us to go over them. So we can identify whether the X is equal to 0 or not. If X is equal to 0, then then there's no numbers that there's no numbers, and it would add up to 0, which is true in this case because the list would sum up to X equals 0. But if X is not equal to 0, then this question will be false because there's no numbers in the set. And if at any places where X is less than 0, then it will be false, because there's no negative numbers in this set. Is there any question in the base case and the subproblem case? Okay, so let's go back and let's go back and talk about the whole thing. So we have 4 subproblems if we identify the base case together. So if let f of k of x be true, and if the subset A0, A1, A2 till AK-1 adds up to X, where k is less than equal to n. So if f of n 0 and 0, that is the case where we say the set is empty and x is equal to 0. So that would be true in this case. And another case would be if f is f of x 0 and x is not equals to 0, which is the case we identify in the base case, and that will be false. And if f any subset where x is less than 0, it will be also false because there's no negative values in this set. Okay, so if it's any other case where f of kx, there's two cases that we can go through. So f of k minus 1 and x minus ak minus 1 is using ak minus 1 in this case. And another case where if you don't use ak minus 1, it will be f of k minus 1 and x. And that's an or between that, because if either of them is true, that means that this whole thing is true. So we use or in this case. Is there any question to this? Okay, so this is a code for what we just talked about. So what we just talked about is just a recursive solution for this question, where the base case is listed there. If k equals 0, return target, which is the sum, equals 0. And if target is less than 0, we return false. So, and also, we identify two cases if it's a case where f of k and x. So it's subset with ak minus 1 and subset without ak minus 1. And we OR these two cases, and when we return it with the answer. And the top-down dynamic programming solution approach is pretty similar to the solution that we talked about, but top-down DP is mostly just memoizing. So as we know, memoizing is to record every solution we got from the subproblem, and then if we re-hit the same subproblem, we can just drag it from the array or the vector. So in this case, we make a vector of unordered maps where it's called memo. And then we will see if the value exists in the map, we'll return it. It means that if the value is already determined, it's already calculated before, we can just get it from the map. So a little bit tweak in these in the blue part would make this a top-down DP solution. Thank you.